Welcome back to Rommel Vlog. Don't forget to like, share, and subscribe. So in this video, we are going to learn the indeterminate and L'Hopital's rule. So um, now on how we are going to evaluate the indeterminate form and how we are going to apply the L'Hopital's rule. Okay, indeterminate form is a mathematical expression that we cannot be able to determine the original value even after the substitution. So indeterminate forms conveys idea that the limits cannot determine without additional work. And also, um, if the indeterminate forms, the given is in forms of indeterminate, we are going to apply the L'Hopital's rule as additional work. Indeterminate forms looks like this. We have 0 over 0, infinity over infinity, and also infinity times 0, infinity minus infinity, and 0 to the power of 0, and 1 to the power of infinity, and also infinity to the power of 0. So now we're going to evaluate each limit. So we have two example. The number one example is that the limit of x approaches to um, x to the power of 2 plus x minus 6 over x squared minus 3x plus 2. Evaluates what or if it is indeterminate or not. To plug in the value of x, so we have the 2 squared plus 2 minus 6 is equal to 0, and 2 squared minus 3 times 2 plus 2 is equal to 0. So the given is in indeterminate form. So now we are going to apply the L'Hopital's rule, which is additional work, and we can get the value of our given. Okay, so in L'Hopital's rule, we have limits of x approaches c, f prime of x over g prime of x is equal to limits of x approaches c, f of x over g of x. So the given, we have the numerator and denominator. We derive the numerator and also the denominator. So in derivatives of each term, so we have x squared plus x minus 6 and x squared minus 3x plus 2. So we derive each. So the derivatives of x squared plus x minus 6, so we have 2x plus 1 and also 2x minus 3, the denominator. So in this form, let's try to plug in the value of x, which is the 2. So to plug in the value of x, we have 2 times 2 plus 1 and also 2 times 2 minus 3. So the result of this is 5 over 1, which is the final answer is 5. So the limits of x approaches to x squared plus x minus 6 over x squared minus 3x plus 2 is equal to 5. This is our final answer. How about if our given example is trigonometric function? So let's try. Okay, we move on. In our example number 2, we have evaluate each limit. So our number 2 is limits of x approaches 0 equals e to the power of 2x minus cosine of x over x. So we try to plug in the value of x. So we have times 0 minus cosine 0 and also 0. So it is 2 times 0 is 0. So 8 to the power of, or the natural log of to the power of 0 is 1, and also the cosine 0 is 1. So 1 minus 1 equals 0. So we have equals to 0 over 0. So the given is indefinite forms of 0 over 0. Okay, so now let's proceed to apply in our L'Hopital's rule. Okay, apply the Lupital's rule. So we have the limits of x approaches 0 of a to the power of 2x minus cosine x of d over dx. So we have to derive its the numerator and also the denominator. So the derivatives of a to the power of 2x minus cosine x. So we have the a to the power of 2x times 2 plus the derivatives of negative cosine x. So we have positive sine x, and also the derivatives of x is 1. Okay, in this term, let's try to plug in the value of our x, which is 0. Okay, so we have the 2 times 0 to the power of 2 times 0 plus sine 0 and also over 1. So we have 2 over 1, and it is, our final answer is equal to 2. So the limits of x approaches 0, e to the power of 2x minus cosine x over x is equal to 2. This is our final answer in our example number 2. Okay, so that's all for today's video, and I hope you like this video. So please don't forget to like, share, and subscribe.